Hello, ladies and gentlemen. It's your daily dose of Dorfler today. It's gonna be a quick dose today. I'm just checking in to see how you are going along with your neutralization reactions worksheet that I gave to you the other day. Again, the day that this is being released, just a reminder that I'll try to be on Google Classroom towards the beginning of class, and if I see no one's hopping on there for a Google Meet, then I'll probably get off. That's maybe halfway after 15 minutes, 20 minutes or so. So just to let you know, I will be on there. So if you do have questions, feel free to hop on. Anyway, just want to go over a couple of these with you. Let's look at B. We are to do a balanced chemical equation as well as a net ionic equation. So not only are we need to pay attention to the fact that we're dealing with neutralization, so acids and bases and the like, but we also need to also keep in mind the solubility guidelines when we are putting our substances together. Okay, so we're going to go over just a few of these problems just so you can kind of see what I'm talking about. So B, we have H2CO3, which is carbonic acid. I'm just going to go ahead and write this down. And although it doesn't say the states here, based off of our solubility guidelines, we are able to determine whether or not something will be a solid or aqueous or liquid state. So I'm kind of leaving some space here so I can go back and add the states of each substance. And here we have strontium hydroxide. Okay. Now, funny thing about strontium hydroxide is hydroxides typically are not soluble unless they are bonded with certain elements. And one of those certain elements will be strontium. And strontium also just happens to be a substance that when bonded with hydroxide makes it a strong base. So here we have a strong base. So this is aqueous. Okay. H2CO3 is carbonic acid. You don't even see what I'm showing you here. Okay. H2CO3 is a weak acids, carbonic acid. It's the same type of acid you have in your soft drinks. Okay. So it's aqueous, and that's going to play a role. That says AQ when we start to do our ionic equations. So, excuse me, much like before, we're going to do our components. Strontium's going to go with carbonate. Hydrogen's going to go with the OH. Again, because we have to have a salt and a water when we have acids and bases mixing together. And we are going to have H2O, which is going to be a liquid, plus strontium carbonate, SrCO3. And if you look at the solubility guidelines, you will see that that is actually insoluble. So it is a solid. All right. And got to make sure you balance this here. And really the only thing it takes is a coefficient of 2 in front of the H2O. If I can get some room here. Okay. So now we go ahead and dissociate what we can. Well, see, this is our molecular. Then we have to do our ionic. H2CO3 is a weak acid, therefore weak electrolyte, and does not completely dissociate. So it just gets rewritten like original. Strontium hydroxide, however, is going to be dissociated into its ionic components. So that's strontium is 2 plus aqueous plus OH minus, you need to put a coefficient of 2 there because that 2 goes right into here, okay? And that's also aqueous. Yields 2H2O cannot be dissociated because it's a liquid, plus strontium carbonate, which is a solid, can also not be dissociated because we cannot dissociate liquids or solids. So what we wrote initially down as our ionic actually becomes our net ionic. You cannot break these down. You cannot remove any spectator ions. So this is your answer for B. H2CO3 aqueous plus SR2 plus aqueous plus 2OH minus aqueous yields 2H2O liquid plus SrCO3 solid. That's your answer for B. And if you need to, pause the video and you can write that down. Okay, let's see what else we should do. Well. Let's do F. Okay, F's a little different because it gives you the word format, not the formula format. So we have aluminum hydroxide and hydrochloric acid. Again, we need to do a balanced chemical or molecular equation before we do anything else. So we have aluminum hydroxide. I'm getting these formulas based off of what we did in chapter 2. Again, I don't know. I'm going to investigate what the states are after I get everything written down. Okay, plus hydrochloric acid, HCl. Well, we know that hydrochloric acid is a strong acid and it's going to be aqueous. Okay, they are going to do-si-do. Hydrogen again is going to go with OH. Aluminum is going to go with chloride. Form our ionic substances of aluminum chloride using the appropriate charges. Okay, excuse me. And aluminum chloride is a soluble ionic substance, so it gets aqueous, and we also get H2O, liquid. Okay, so now I need to identify what the states of matter are. Aluminum hydroxide, again, we mentioned in the previous example that hydroxides are typically non-soluble unless they're bonded with an exception to that rule. Aluminum is not that exception. So it actually is a solid. Okay. Hydrochloric acid is aqueous, as we said. Aluminum chloride, it's a soluble ionic substance based off our rules where we need them. And then we have H2O, which is a liquid. But we do need to balance this before we move on. Again, if you want to stop this and balance this on your own, you can. And if you do so, you can check. Put a 3 in front of the H2O and a 3 in front of the HCl. So that's our molecular. Next, we need to do an ionic. And so we need to dissociate what we can. Well, we cannot dissociate solids. So we don't do that. Hydrochloric acid is a strong acid. Therefore, it can dissociate completely. So we get 3H plus aqueous. Again, that 3 comes from the coefficient. Plus 3Cl minus aqueous yields Al3 plus aqueous plus 3Cl minus. Again, that subscript of 3 goes with the with the chlorine. Aqueous plus 3H2O liquid. Okay. So now we need to figure out who did not change from beginning to end. And we see that really the only thing that did not change from beginning to end would be the chloride ions. Okay. So they can be removed as spectator ions. Aluminum went from a solid compound to an aqueous situation. And we're going to be talking about these ionic equations, net ionic equations, in the next section when we start talking about what's called redox reactions. Okay. So basically everything else besides the chloride ions has changed. So our net ionic in our answer to letter F will be AlOH3 solid plus 3H plus yields Al3 plus aqueous plus 3H2O liquid. Okay? Excuse me. So there you have it. That is how you solve one of those problems. So I told you way back in chapter 2 that this book continually builds on itself, and this is proven to be, truth to that statement, where how we take the names of the formulas or the substances and then create the formulas based off of ionic charges is a must. Okay, got to get that down. So anyway, again, if you have any questions, hit me up at a message, private message, or an email. If you don't catch me on Google Meets, I will be on Google Meets during your regular class periods. The day this video is coming out, so that would be the 7th of December. So just be aware of that. Keep working on that. Make sure you finish this and get it submitted to the portal that we found your assignment in. So anyway, I'm going to end this short video and tell you have a good day. I will see you later. Bye-bye.